This is an algebraic identity. Everybody's pretty familiar with this one. A squared minus B squared is equal to actually, no. This is just the straightforward. I'll give you a hint. A plus B times
A minus B.
A minus B. It's just a straightforward algebraic identity. For any A and B, this is true. To verify it, all we have to do is multiply this side over here. By multiplying it, we get A squared
AB
plus AB minus AB minus B squared. And don't these two give you 0? And I get A squared minus B squared. Does everybody see I multiplied this side or simplified this side and I got this side? Notice that it's not like an equation. What I did was I multiplied on this side or did something until it looked like this side. Got it? This is verifying an identity. Now I'm going to show you a new one that's kind of like this, and you'll need it for today's assignment. It happens to be A minus B. Does everybody see that I need an A cubed here? Isn't A times A squared equal to A to the third?
Yes.
Now, does everybody see how this one has A squared minus B squared, and I went A plus B, and then I went A minus B? Okay, watch this. I have an A minus B, so don't I need an A plus? Well, what I need is actually I'm going to need an A B. Yeah. That's my middle term. My last term is going to be B squared, and I need a plus B squared because negative B times B squared gives me negative B cubed. Now the thing to remember is that these signs are different, okay? Now what I'd like you to do is multiply this out, and you can see that it's going to be true. Now to multiply this, I like using the distribution method. So I'm going to multiply A times everything, and then I'm going to multiply B times everything. Well, actually negative B. Multiply this out. I multiply the A times A squared? A cubed. A times plus AB?
A squared B.
A squared B. And then A times B squared is AB squared. We usually write them in alphabetical order. Now I'm going to do the blue ones, and I'm going to multiply by negative B times everything, and I get negative BA squared, which is the same as negative A squared B, because I can write it in order. Notice I just switched the terms around a little bit. Negative B times AB is AB squared, but it's a negative because I have a negative there. And the last term, B cubed. And notice, this is 0, and this is 0, and this looks a whole lot like this. We use identities in algebra to solve equations and to factor. We use especially this one. This one is very common. Use this over and over and over again. X squared minus 1 is x plus 1 times x minus 1, and so on. We use these often too, but these are a little more complicated and they're a little harder to remember. Now there happens to be another one with the a cubed plus b cubed. Let's go ahead and write that just to remember what it is. You saw this before, but you probably don't remember it. It's a cubed plus b cubed. We're not going to multiply this one out. I'm just going to write it out for you. I like to start with the a plus b, just like I started with a minus b for this one, huh? But you see I have a pattern? Now, does everybody understand I need to start with a squared? Now, before, didn't I have opposite signs for the first pair? So I have an opposite sign, minus ab. Now, with the last one, does everybody see I need to have a positive? A positive b times a positive b squared gives me my positive b cubed. This is the correct version for that. These are algebraic identities. They're different than trig identities. Trig identities, the way they work is that they give you something that's always true. Now I'm going to go back to something I went through with you before.